The dryer. Hey, I really expect yeah, I was gonna say that. Rose for how about I can't. I mean, I like to like Christ, I don't five of us wrong in the same. Yeah. I never seen you. Actually, you're my class. This is my class. Yeah. From my I'm so sorry. Nah, you're chill. No, I only know you because you be talking more than expected. Other than that one dude at the front. I am that guy. Is it annoying? No, I mean, I keep it smart from like. That's what they get. I think I have okay. Hey, last day of class. We all have right range traps, so all students. Oh yeah. Like one day class. If you like well on the next test, that's so right. Well, I mean, yeah, but I've already. Yeah, I was thinking about it. So yeah, mega five. You know, I like from that way. It's like how's everybody doing? Cool. So thank you all for coming. This is the fifth lesson of the web dev. What we're recording now. So this week we'll be going over databases, server functions. You can see Mongoose here. And basically just going over what we at Hack for Impact do in terms of most of our application backends. When I say backend, you might have heard the terms backend and front end. Front end is just what you see on the application. Backend is kind of what goes on behind the scenes. So any data stuff, any stuff that goes on that you don't really interact with directly is what we refer to as the backend. But let's see. So just to recap, last week we went over APIs, what they do, how we use them. So APIs are basically how two different applications or the same application can talk to each other. So we saw the Pokemon example where there is a database of Pokemon information and we were able to use the API to hit the Pokemon database and then retrieve some information from it. What's that? Right, and we also went over how there were a few HTTP verbs that kind of allow us to specify what action we want the server to do, right? So if we use get, it's kind of telling the server, all right, give us some information. We want something from you. Post is saying we're here, we're giving you something to do with. Most often it's create it. And then delete is obviously take something that exists on that server or on that database and then delete it. So what really is a database, right? So all these APIs that we use, the information has to go somewhere, be stored somewhere. And that's what a database is, right? So you can think of a database essentially as like a glorified computer that exists somewhere that's really good at holding a lot of information and then giving it to you very quickly. So basically, they just store data that we can use. Pretty simple. So MongoDB, DB is database, is what we use here at Hack for Impact. A lot of companies in the industry also use it. It's really powerful. It's really powerful for this particular reason, because we can store almost any form of data in it. Which, text, which is one of the most common, but we can do videos, audio, images. It's really good. And that's really powerful because let's say we're building an application similar to Twitter, and then later on in the process, we're like, oh, well, what if we want users to have like a little video that plays in the background when you click on their profile or something? It's really not that much of a pain in the ass to actually put that in when you've already done a lot of development. You don't have to like link different databases together if yours didn't do that. So it's really flexible. So if you mess up or you don't know what your fully fleshed out product is going to be, you can actually add that in as you go. So it's super nice for that. So inside of MongoDB, there are a few important terms that we need to go over. The first is DB, which is just kind of the overarching database. Then we have a collection, and then we have a document. So can you guys see this graphic all right? So we have what we can see is the whole database that encompasses everything. Then we have these collections, which you can think of as collecting similar types of information. And then inside of each collection, we have a document, which represents what you can think of as a single instance of that information. So to use the Twitter analogy, we could have a collection for users, we could have a collection for tweets, and each document would be a user, and then each document in the tweets one would be a tweet, right? So you can think all the users are in one, all the tweets are in the other. And that's how a lot of stuff is stored in Mongo. And then we have an ID, which is just an identifier that allows us to refer to an individual document. So if there's a specific user we want to, talk about, or a specific tweet, it'll have an ID attached to it, and that's how we can refer to it in the database. We'll see an example of how that works in a second. So, Mongoose is something that helps us structure our data. Actually, it might be better to actually hop into the code here. So, for anybody who does want to follow along, if you have Mongoose if you have MongoDB and MongoDB Compass installed, you'll be able to follow this pretty easily. So what I'm going to do to show you what we can do here is, let's see here, go to our week 5 folder. Now, Xavier was kind enough to write most of this for us. So to show you an example of how MongoDB works on a very high level, we can do this npm run, or first, actually, we need to go into Compass. Sorry. So here we go. So I'll wait a second for anyone who wants to follow. Just let me know when you can. Yes, yeah. So yeah, I think if I create a new one, I think I've already done a connection. So yeah, let's see. Oh, over here. So if you are in Compass, which you can think of Compass as your like little insight into the database, what I can do is create a new connection, and mine defaults to 27017, assuming most everyone's is going to. So that's the one we're going to use, and I'm going to hit connect. Let it spin. Yes. So, in Can everyone see this? All right, it's kind of bright. See if I can pull this up. So what we can see over here in Compass is we have our connection up top. So this is a local host connection, but this can connect obviously to a remote database for a real application. For this, we're just using localhost. And then we can go to our databases here. We can show the different databases that we have. They also appear over here on the left to very easily switch to. But if we go here, yeah. And then we just have a few other tabs. The one we're going to be focusing on is I already have had it created, but for you guys, what you're going to do is create a new one. And we're going to call it, I'm just going to go ahead and delete this, to be honest. So we can create a new database, and we're going to call it WDW for Web Dev Workshop. And then inside of this collection name, we're just going to create our first collection, which is we're going to call users. The reason we're calling it users is because the kind of example we're going to be following is a small, simple version of Twitter in terms of data. So, yeah, so we're going to have users, and eventually we're going to have tweets. But yeah, so is everyone here, and has anyone had any issues getting here? What does it tell you? Oh yeah, it might not have the server part, like the yeah. I think it's just MongoDB. Yeah, let's see. Let's see. Yeah, if the link in the Discord, if you follow that, I think it should have some steps to download it real quick. Oh, let's wait a second. No big deal. It doesn't want for you either. This is something to look at the database. It doesn't actually establish the database. MongoDB and yeah. Yeah, that's it. It's probably a pretty. Don't think so. Cool. Yeah, the first steps honestly don't need to follow those. Cool. So while y'all are downloading that, we can actually continue because the first steps aren't really too interactive anyway. So let me pull this up so you can see it. So if we run this script that we've written, which is called npm run populate users. Oh, I need to install. All right. So now if we run that and just yeah, what am I doing? There we go. Awesome. So let me pull this up so you guys. So if you can everyone see these things down here? Yeah, we'll look at that in a second, but I just want to show you the IDs. So if you remember when we talked about IDs inside of MongoDB, that is what these are for, right? So we have this massive string of random characters, pseudo-random, that just kind of serve as an identifying token for each of these individual documents. So if we go into the code here, it is, let's see, just create user. Actually, we'll just go ahead and create user. So, actually, is your guys' stuff don't download it yet, or it is? Can you connect yet? Okay, sweet. Anyone still hung up, or are we able to keep moving? Okay. So that was how we can see that we got an actual identifying token. And if we look inside of Compass, we can now see that those two users are now have been created and put inside of our user collection. Right, so these two things, documents, instead of our user collection. So what we can do now is create a way for us to actually create our own users and put them into the database ourselves. But before we do that, I want to go over Mongoose and what Mongoose is. So what Mongoose does is it actually helps us structure our data. So it makes it easier for us to use it. It makes it a little bit safer, because otherwise we can kind of put whatever we want to inside of our database. And we don't want that, right? We only want users in our users collection. We only want tweets in our tweets collection. And it makes it a lot safer, and we avoid that problem of accidentally putting a tweet in the users collection or something like that, which is very bad. So to do that, show you how this works, if we go to the code here again, I'm going to open this find by IDs thing here. And what we can see is that we have this user schema dot find by ID. And what is this fancy word schema? Well, a schema is what we use to add that structure, right? So we create a schema using Mongoose. If we note here, Mongoose is imported up here at the top, allowing us to use it. We can now use and create a new schema, which defines the structure of what we want our user to follow. So we can see that we want a user to have a username, an email, a name. Are they verified, or how many followers do they have, right? This is meant to kind of emulate Twitter, right? So verified followers. And then we can also note that some are required here, right? So name is not required, it's false. An email and a username are required. And then we also have these default values for being verified and for the number of followers. Default meaning if we do not specify it, it will just use this default value. So if we create a user and we don't tell it to make it verified, it'll always make it false. And the same thing for the followers, it will always go to 0 unless we say otherwise. So,
just to do a quick recap on that, all of our database interactions go through Mongoose. Our server here never talks directly to the database, it always goes through Mongoose. Mongoose does makes that database interaction very easy to do with just one line of code. And it also gives structure to the data. If we are thinking we're making a database for Twitter and all the users on Twitter, if we are trying to create a user, Mongoose will make sure that that user has all the information that we just went over. Have to have an email, and have a name optional. You have to have a verified status, you have to have a number of followers, but those can have a default value. And additionally, we're getting a user back to the database. That will also go through Mongoose, and it'll also make sure that it has all of the same data and nothing corrupted.
Yeah. Mongoose is an incredibly powerful tool. But if we go back to our find by IDs, so this is finding a user by an ID. Well, if we go and find one of those IDs for a user, which we know are in Mongoose that we can see in our documents here, we can then, why can I not copy you? take one of these IDs, so this one is for John, and go back to our code, and then paste it into this function here. And then run find by ID. Boom, we can now see that we have printed out through this console.log here. Let me bring this up. We can now see that we've printed out all of our information that is the exact same as it is in Mongoose, right? So we got all of that data that we put in, and we got it right back.
Push the button up on the code, how it works, doing. Supplied an ID, and it looked at the database, looked for the user with that name. What is Mongoose? So just like our, we'll get into the later, but probably you. Just like our APIs and our client server kind of acts as the middleman, Mongoose is the same for the server and the database. So never talk to the database directly, just like the client never talks to it.
We got to play down to Mongoose version a lot back.
It's in the project. For our project, there's a server function thing called which have Mongoose. We'll get to that later.
Yeah, it's a if you run like npm install, it's like a package that gets installed with that. So and then to obviously rehash this, this is a really common thing you'll do is refer to a specific document. If you want to refer to something specific, you use the ID. That's the way that we do that. So yeah, so that's how we can get one of the like an individual user. But let's say we want to get all of them. So we can go to this get all here. Let's see. So if we go here, and to get all, right? Remember last time what we did is we specified an ID, but I'm going to take this one line at a time here. If we create a new user variable, and we're going to wait on this, and I do want to point out, right? This stuff is the tricky asynchronous things. So a database call, similar to an API call, is an asynchronous thing, right? So you can always think of if you're reading data from somewhere, it's an asynchronous operation. It's going to go and do it on its own, which means that we want to make sure that we wait on this to connect before we continue. Otherwise, obviously, it's not going to work. And then we do the same thing here where we want to wait on our function to complete as well. So we can use our user schema and .find, right? So that's how we get things. So instead of find by ID, it's just find. And then we tell it what we want it to kind of find by. Since we want to get everything, what we can do is tell it find by nothing, right? We pass in essentially nothing here, saying there's no thing to keep out of, right? And this will make a little bit more sense in a second. Yeah. Jesus. And then to show you, that's not where that's supposed to go. We can console.log our user to print it to the console.
All right.
You can use those on the side. It might be a little easier. If you use the middle buttons.
All right, everybody. Got a little bit clear contrast. The red.
Yeah, I was trying to find a color. Anyway, if we run enough commands, npm run get all after writing our code here, what this will do is actually pull up, I guess it would be users. We get all the users that are in our selection here, right? So we got both of them. Now, right, we passed in nothing here, and that's a little bit unintuitive. But let's say we want to only get the users that are verified, right? You can see this here. We have John. John is verified. So what we can do is we can say is verified and specify that to true, right? So what we're saying is, all right, only look for the users where is verified is set to true. and only give me those back. Now, if we run that again, we should only get John back since it's the only one that is verified. Yeah, so the way I like to think of it as basically, let's see how
we need a band for the braces. Yeah. You need to be more specific to by default, so you can.
Mhm.
And that's the way you set up the right?
We didn't set this up, it's just kind of long, so.
Yeah, so this user schema.find, right? User schema is a Mongoose thing specifically that we use Mongoose to create. And this find method or this find function is a Mongoose function. Same with that find by ID, that's another Mongoose thing. So that's just one way that we can actually tell Mongoose what and what not to give us. Cool. So what we can do now is, right, we're doing a lot of reading users, but if we want to actually create a user, that's fairly simple as well. So what we want to do is create a user on our side first, and then send it up to Mongoose or through Mongoose to our database. So I'm going to create a user, right, and create a user object, and I can give it a username of, I don't know, Alex, or Alex.Austin for username. And then I can set the email to Austin at gmail.com, something. So, right, what this is doing is we're creating a user on our end. And then what we're gonna do is actually send that user up to Mongo. So we're gonna create a new variable for our created user that's created on Mongo. Wait, our user schema dot create, and then pass it our user. So what this is doing is we're saying, all right, telling Mongoose through our user schema to create what, if we specify what we want to create through the object that we created here, which is our user here. And then that actually returns the object that we created. And just to show you that, we can actually print that out as well. Yeah. Yeah, create user.
Like something closer to Twitter with like 1 million users, how would you like multiply that? So when
That's $1 million question right there, man. Yeah. So
million things behind the scenes that MongoDB does.
yeah. So the people at Mongo do a ton on their end to make this stuff really quick. You can also do something like, I don't know if they specifically do it where what? Yeah, whatever.
We don't have to worry about a lot of that performance stuff.
Yeah.
Worries about most all of that.
Yeah. Unfortunately for us, we don't have 2 million users on the things we make, so that's not too big of an issue. If you're curious, there are a ton of stuff that you can actually like read the articles on, like in talks that people at companies like Twitter and Google and stuff have actually given that go into their optimizations. But yeah, that's actually a really interesting question. I wish I could give you a real answer. But if I did, then I'd probably work at Twitter. So and that's printing out the wrong user. We need to print out the created user. But that doesn't matter anyway, because I can show you on MongoDB Compass right here. If I refresh with this button here, we can now see that we have 3 users. Can I scroll up? That does not help. Down here at the bottom, if you are able to see it, my new user with Alex Austin, my email is now created. And if you are able to see this, the is verified and no followers fields are actually been set for us, because if you remember, those had default values. If you do notice, one other thing is that our name is not here. And we got no errors. That's perfectly fine that we did not specify a name because we set it in our code, in our schema, to, by the way, if you hold control and click on that thing, it'll take you to where it's defined. So that's how I move into this. But if we look at our schema here, right, these email and the usernames are required, but the name is set required to false, right? So they don't complain when we don't put in a name. But if you notice, we didn't put in it is verified or a number of followers either, and it didn't complain. And the reason why is because we actually gave this a default. So it says, okay, you didn't give us if it was verified or not, but you already said if we don't do that, defaulted to false, no problems. So this is really powerful and really useful as well. Save you from a lot of trouble. Sweet. So that's creating a user. Now, how do we delete one, right? So deleting a specific thing, right, is done very similarly to retrieving a specific thing in MongoDB, which is through an ID. So if we go over to our delete user.ts folder or file, we can now just do an await our user schema. And you can see that every time we want to do a database operation, we do it through our schema, right? And that's basically doing it through Mongoose, right? Think of your schemas as Mongoose. So we can do find by ID and delete, right? So Mongoose comes with this absolutely perfect function right here. It just says find one by its ID and then delete it. And all we have to do is pass it its ID. So I'll just go ahead and take myself that I just created and delete myself. I know, right? How's that? Oh, there. Cool. And now we can actually go ahead and run this and see that we can delete us. Now nothing prints out here because I didn't print anything out, but if we go back to Compass and refresh, I am gone. I'm no longer here. And yeah. Now it's actually really cool. I'm actually super impressed with MongoDB with how easy this stuff really is. Deleting, creating, and getting have also been one line of code each. And if you haven't used anything like SQL or SQL before, it doesn't hit you as hard, but that's truly amazing how easy that really is. And it's a really powerful tool. So we mentioned collections earlier, right? So far we've only been using the users collection, but if we're Twitter, we're going to have users and we're going to also have our tweets. And well, we need them to be able to reference and talk to each other. And like, a tweet has someone who posted that tweet, a user who posted it, or we're going to call that an author. And so when we get our tweets, we want to, actually get who posted it back as well. So what we're going to do is go to our create tweet here. And first we have to actually, put some tweets into our database first. And I do want to point out in Compass, we still only have the users collection. We don't have any other collections yet. And Mongoose does happen to handle this automatically for us, which is pretty sweet. So if we go, I'm actually going to pull up the schema first, right? So our tweet, so we had a user schema. Now we're going to have a tweet schema, and we're going to do all tweet operations through this particular schema. And take particular note of the author. And do that because we have our type here, right? So this one is the type of a string. So content is just the text in the tweet. Of course, that's just text strings. Now, author is the user who posted it. And this is where it gets slightly more complicated. And we use this schema.type.object ID. And what that is saying is refer to an object inside of any collection with that particular ID. And this ref is telling us which collection or which, I guess, schema. I'm gonna ask you something later. Collection. Okay, yeah. So yeah, that tells us which collection we're referring to. So if we go back and make a tweet, we have to first put in author. And what that author wanted was an ID. So I'm gonna go back and grab a, we'll do Jane has posted this tweet. And then make sure you put it inside of strings. And then our content could say, this is a tweet. And that's our object or our JSON for our tweet. And then now we can do just like we did with creating a user. You just do await, and then instead of user schema, it's tweet schema dot create, and then our tweet. Cool. Now, we can then run npm run create tweet to create it. Sweet. Now, if I pull up Compass again and refresh this, you see we now have two collections. And we can now reference our tweets. And you see that, oh, this is the tweets object ID, by the way. And then we have the author, which stores this object ID. So don't get these two things confused. It's pretty easy to. But this underscore ID is the ID of the tweet itself, or this tweet document. This author is the ID of the author who made it in our users collection. So that works how that references the other. Cool. So what we can do is if we want to kind of get all of our tweets, let's see, get tweets. All right, we just do what we did earlier, where we pass in nothing, and this should return us all of our tweets. Cool. Now, this isn't quite what we wanted. If you see here, our author is still just an object ID, which is close, but we want the actual content of the author. Right now, we just have to go make a whole separate database call using this if we want to refer to that user. And to answer an optimization question, that would be slower, right? If instead of making two calls, we'd rather make one. So we want to combine that into one. And the way we can do that is using a really nifty function on top of this called .populate. And the way I like to think of populate is you're saying populate a certain field. And in this case, we're going to be populating the author field. And what we're populating that with is just the contents of the user that is referring to. So author, that's right, I did. So kill that. Let's go twice. Get this again.
Well, that's right. I want to reiterate what the difference between what we just did before and what we just added now. So if you're picturing Twitter, you're scrolling through tweets, every tweet has an author. If you scroll up,
like here's
the previous call.
Oh, well, I cleared it, so it's gone.
The previous call, we just had an author, and then it just had an ID. If you're scrolling through Twitter, you don't see, author, and then you see a long string. You see author, and you see a name. So one thing we could do is we could get the tweet, get the author's name, and then go back to the database, and then get the author's name. That's two database calls. That's kind of inefficient. That's not very good. So instead, we use this .populate. You can carry on.
Yeah. So you can see this is pretty useful. We can now actually reference one collection, or we can use one collection to look at another collection, and that's incredibly useful, as Andrew just described. So, I think that's invalidation. Oh, the docs. So, if we go here, want to learn more. Oh, just Mongoose documentation, right? And just this one. So, right. So a lot of these tools can get overwhelming, especially if you've never used them before. And the best way to learn them, especially when you're kind of stuck on something, is to look at the documentation, right? So Andrew, you asked a second ago, like, what is Mongoose? Like, is that something you have to download? Boom. npm install Mongoose, right? So just through reading this, we already know a little bit more. So, right, well, we know it's asynchronous just by looking at these async and awaits here. Here's our local thing that we just did.
The thing I want to emphasize here is if you have a question about what can I do with Mongoose, Google Mongoose update a doc, Mongoose create a doc, Mongoose delete a doc.
Yeah,
We
I
never
like it.
memorize all of this code, right? If you look up Mongoose, how to do this.
Boom.
Man,
How do I
it's just-
create a document? Oh, what? I just create that, and then I do that.
So we just very quickly wanted to say that look at the docs and they're available if you want to learn more.
And this just goes for almost anything that you use. If you're learning Java, if you're learning C++ or whatever classes you're in, if you run into an error, like I think oftentimes the most valuable thing you can do is to literally just copy paste the error into Google. And oftentimes someone from 15 years ago who had that same thing got it fixed. So, but yeah.
And one last thing in the code that we didn't talk about, but it's there.
No problem.
How did we actually connect to the database and say, go put this user here, go get this tweet from here? How do we say where that database is? Well, we actually call this function called DB connect. This is something that some tech lead wrote a few years back, and we've just used it ever since. That's actually what connects to the database. It says this is where I'm getting my users from. This is where I'm putting my. Don't need to worry about how that works unless you want to. Be happy to explain. It's pretty cool. But just so you know, that's the work.
You wrote that?
Come on.
God, that is such smart. All right.
One of y'all.
No.
It was back when we were freshmen.
Yeah. So yeah, when we were freshmen, one of the guys who was kind of, I guess he was what, senior? Yeah. He wrote it.
We've reused it ever since.
Yeah.
Good.
Cool. Any questions on any of that stuff? One kind of quick. Like what's a document? What's a collection? Anything? There's no way all of you guys got that. There's gonna be a question. I'm talking about. Cool. All right, you get to talk about Squad now. Yeah. How many is that shit? Think you really made slides for all these? Oh, I guess this is where you are, right?
Yeah, okay.
Oh, like motivating example or? Yeah, you got it.
Okay, so we looked at kind of storing data in the database, getting data back into the database, but we want to go a little bit further and talk about different types of data. There are three main types. If you are on my team, you've seen some of these before. The kind of classes of data. You have request types, response types, and entity types. They all serve different purposes in our code. So let's say, could you open up the user schema? Let's say I want to create a user. We saw this before. I had to supply a username, an email, and I could supply a name. What I didn't supply is the is verified field and the number of followers, because those will always be the same for every new user, no matter who's creating it. I'll always start out with 0 followers. I'll always be unverified by them. So if we're kind of thinking, I'll give the database something and it'll put it in the database. Maybe I could be a little bit sneaky and actually give it a number of followers, set that value to 10. If we were to write this in code, we could do that and give me a little boost on my follower count. Even though I shouldn't be able to. This is where a request type comes in. Even if we store more information about a user, if I'm creating a user, I want to have a data type that's probably called create user request. And this is where it kind of gets into like the Java classes. For TypeScript, it's our TypeScript interfaces. And it specifies exactly what data is used to create. So that data type would likely just have the username, email, and name. I wouldn't be able to type in either of these fields. That's a request type. If I'm asking the database to do something, create something new, I have a request type for that. Let's say I wanted to update a user. I could have an update user request data type. Question of what that is, what purpose it serves. All right, next up we have the entity type.
Types. It's odd.
Can you do the get tweets?
Yeah.
Entity type represents exactly what is stored in the database. No deviations from it. So again, the request type is not necessarily connected to the database. We didn't specify number of followers. We didn't specify these variables. This here is an example of an entity type. If we had a tweet that has an ID, an author that's also an object ID, and then the content. That's exactly what's stored in the database. If we could actually open up Compass, you can see it's the exact same. ID, content. That is used usually on the server if you're doing some operations and just want to interact with exactly what the database is. The third type is a response type. And this is what the application will actually be doing. So kind of what the entity type is, what's in the database, and the response type is kind of what you end up using at the end. So our example of a response type was if when we did that dot populate on the tweets. We'll see that this actually differs from what's in the database, but this is how we want to use the data. So this is a response type. The difference here is that now an author has ID, username, email, name, is verified, and number of followers. There's the difference between the entity type and the response type. Questions about that? Why? And then if we were thinking about what a user entity would look like, a user entity would look something like this, because the ID all the way down to number of followers is exactly how that user is stored in the database. Sometimes the entity and the response are the same. It would be like that for a user, but it's important to distinguish between them so that you know how you're using your data.
Let's see what's next. Bad data.
Yep. All right, and so just kind of an extension of this, what happens when we get bad data? When we get to the API, the client to the API, so if I'm trying to create a user from twitter.com, log in twitter.com, hit the sign up button, and it will send a create user request over to that API. I'm not necessarily creating a user, or for this example, let's say posting a tweet from twitter.com. I might be posting a little button at the bottom of the BuzzFeed quiz to tweet my results. I might be doing it from any number of places, not necessarily just from twitter.com. And all of that, creating a user, would be done through a create user API. And so if I have a create user request that comes from twitter.com, it can also come from BuzzFeed or Instagram or any other sort of place. And because of that, my data can be received in my API in any format. I'm not guaranteed that it has a name, a username, and an email, and nothing else. So bad data is a really big problem. I mentioned before, I could specify good.
So if like you create a request from like Instagram for them to make a tweet, how does the API know which account is associated with that request? Is that like IP address or something?
Broad strokes, when you make that request, your computer sends over the extra information about who you are without getting to it. I can't afterwards, but that's it. On that level. So if this API assumes that everybody will play by the rules and specify a name, username, email when they're trying to create a user, that's going to lead to a lot of problems. Maybe somebody puts in some stupid code that messes up the system, or doesn't supply email even though everyone's supposed to have one, or tries to falsify their follower count. That can lead to a lot of problems. So we have to guarantee, be able to validate that our data is in the correct format. And that brings us to how we do this with Hack for Impact, which is Zod. Zod is how we actually validate. Go back to the slide.
Yeah.
Zod is how we actually validate that the data that we receive in the API is in the right format. So if I go to, I'm tweeting the results of my quiz from BuzzFeed, I click that post tweet button. The API, kind of like last week, how we talked about whatever we did, we talked about how the API is kind of like the waiter quiz the menu. You order off menu, API will reject your request, so you can't order that. Similarly, when we validate with Zod, which I'll show here in a minute, the API will say, hey, that's a badly formed tweet, you have some bad data there, you're trying to create a user, you don't have the right information, you have too much information, it'll reject that request. So we do that with Zod. Zod, the first thing we have to do to be able to validate, let's say we're trying to create a user, the first thing we have to do is tell the application what a user looks like. Now, we kind of already did it with Mongoose, with that user schema before, but we have to do it again in our API. The reason why we have to do that, you can see I've kind of drawn these lines here. I'm going to call those application values. Anybody can ask Twitter, the Twitter API, to create a user. Because of that, the API has to validate across application boundary. API has to validate that my data is in the right format across that application boundary. If I'm trying to create a user, all my data is formatted properly. API will tell the server, hey, go create this user. The server will then go tell Mongoose, hey, can you tell the database to create this user? And Mongoose, with that user schema that we saw before, actually pull it up. That user schema, make sure again that all of that data is in the right format for the database. Zod, which I'll show you in a minute, validates that the data is in the right format for the server. Mongoose validates that the data is in the right format for the database. What that says. So we said how a user should look like with Mongoose by creating a schema. Similarly, we'll specify how a user should look like for the server on the API level with a Zod type. Show that. Right here, right? Yeah. All right. So this is how you say how a user should look like for the server. We call this a Zod type. This is a user. We've just kind of tacked on a naming convention of putting a Z right before that to say it's a Zod type. Zod is just like Mongoose, the tool we use. If I'm specifying what a user looks like, a user has a username that is a string. It has a name that's a string, that's optional. It has an email that's a string, and you can be really specific here. Say that's an email address. Is verified as a Boolean, the number of followers is a number. We can be so specific with this. We can say this other field should be a number greater than 50. This other field should be a string that has 5 letters, 2 numbers, and 3 other letters. You can be very specific with it. So that's kind of what a user looks like. But remember, we're trying to create a user. And I don't want to specify that is verified in the number of followers field for creating a user. That's not allowed. I'm trying to create a user. I'm not allowed to set those fields. So in order to do that, we're going to specify a request type. And this ties back to the purpose of those different data types. So we have a new Zod type here, a Z create user request Zod type. It's the same as that user because all those fields, except it without the is verified and without the number of followers field. So if you scroll back up, our create user request, go down a little bit. Oh, down. Oh, that's good. Yeah, that's good. So my Z create user request will have the username, name, and email, nothing more, nothing less. Except the name because it's off.
Then we
That's
go
my request type has that date. So,
I was saying, where do you go next?
any questions about that? All right. We had something where we did this validation, right?
Safe parts.
Yeah, what code were you doing? I think.
I don't know, is it like that?
So we did. So
Yes.
okay,
Oh, there we
perfect.
go.
So let's say I'm trying to create a user. You want to go ahead and run that code.
Yeah.
We have an example user here, name, Mr. Pibb, email, Pibb.
That's the design. For the scripts. Editor. Yeah. Wait. Find this. Like, if you ever did. It was, couldn't find the module. Oh, did you do an absolute? Wait, I don't know. Yeah.
We can just go off the
Yeah. Yeah, I'm just gonna copy that whole thing.
Sorry about that. Running a little low on time, so I rush through this. Oh, something bad happened. Why did something bad happen? Let's look at the user that we tried to create. Something really bad happened. I have no idea what that means. As a name and email, what's missing? The username. So what just happened is our API sent a user without a username. Told the server, go make this user, even though it doesn't have a username. And Mongoose said, wait, we need a username. I was applying, and then it just blew up and gave us that whole big unreadable error. So what we want to do before that is make sure that our user has everything that we need. So we go to line 6 and make a variable called validation results. What we can do before we actually tell Mongoose to create that user is validate that the user looks as it should. Again, if you remember, this Z create user request specifies what our user should look like. And then this safe parse function says, hey, this user that we're trying to create, this guy right here.
Which guy? All right.
This user, does it follow the same format? We know the answer to that is no, because this doesn't have a username. So let's do a console that's coming up line 8, and then add a console log and console log validation. Let's see what that gets. So it has, this is an object that has 2 properties. It has success, is false, and error is something else. So let's console.log the validation dot error.
What the hell? Yeah. It's function, all right. That's right, all right. It doesn't like that. Is it a cap? Jesus, dude. Yeah, there's no way that's.
Well, if error did.
Oh, there's this. No, connection parentheses.
If that error could talk, it would tell us it was looking for a username and it couldn't find it. So let's give it a username, see what happens on its validation.
That's totally like that.
Now we have a properly formatted user. Let's see what that dot save parse function. As success true, and then this data thing, which looks like exactly what we gave it. So now that we have a valid user, it'll say success is true, and we can be confident that we can go and put it in the database. Let's try to be a little bit sneaky and specify that I have 1,000 followers. Let's see if I can sneak that through. Just like that. Again, what this is going to do. API will take that in, feed it to the server. Server is going to come on say, yeah, that's fine. The user has a number of followers, it's fine. What does Zod tell us? Did you already run it?
Yeah.
Still says success true, even though we try to give it extra information. But what we get back here is a data object, which doesn't have that number of followers in it. Again, that create user request tells us what a user should look like. All the data it needs, no more, no less. And so if we are wanting to, let's go to the database. Then doing that user can do validation result dot data. So give us this. All the information we need, no more, no less.
Insert him. No. Is there supposed to be a Zod thing here? No, it's because it's this. Yeah, I don't know. Anyway.
Then
Oh well.
but we can be confident that we have updated our data. So get back to slides. That's it. So just to sum those up, everything we kind of talked about, we have now learned all the tools to create all of our applications. We've learned about APIs, we've learned about the client, the server, and now the database. So just to walk through that process again. I'm on a client, I'm on Twitter.com, I'm wanting to sign up, or I'm wanting to post a tweet. And someone else on, BuzzFeed or Instagram or Reddit could click this post tweet button, and it would do the same thing. That will send all the information required to send a tweet to the API. API will check with Zod, like he does everything elsewhere, that there's no more information and there's no less information. We get exactly the information we need. When we specify what information we need, the same request, create user request or create tweet request, something like that. Once the API is confident that the data is received is in the right format, it'll go and pass that over to the server and say, hey server, go and create the tweet. The server, now that it knows that the tweet's in the right format, it will give it over to Mongoose and say, hey Mongoose, can you tell the database to make a tweet? Mongoose will make sure that the data is in the right format for the database. No more information and no less information. So go and create that database. On the flip side, if I'm wanting to get all of the tweets, if I just log in at Twitter.com, I'll probably have my client will ask the API, hey, can I have all the tweets? The API will say, yep, sure thing. Tell the server, give me all the tweets. The server will tell Mongoose, hey, give me those tweets. They'll get all the tweets from the database. Then coming back, what will happen is the database will give all of the tweets to Mongoose. Mongoose will check again, make sure that all those tweets are the right form. What if someone tried to sneak in some extra, some bad data, maybe something is corrupted? Mongoose will capture all of that. So as long as all the tweets look good and are properly formatted, Mongoose will give that back to the server. The server will give that back to the API, which again is kind of later if you think the server in case you remember what we talked about a few weeks ago. API will say, okay, I have all the tweets, and it will give it back to the client. And then one last thing that happens again on the client is the client will check once more. Are all with Zod, are all my tweets in the right format? Because again, maybe between here and here, because these are kind of two separate entities. Maybe some of this data was corrupted, maybe someone tried to put in something extra. By using Zod, we can validate that we don't get anything extra, we have all the information we need, no more, no less. Another reason why that's important, last week with our Pokemon example, we hit that Pokemon API, got that big long list of Pokemon, and we put all their names on our page. That field was just called name, it had the name of the Pokemon. Maybe that Pokemon API changed that field and called it Pokemon instead of just name. Now our front end application, our client, won't work anymore. And if we validate, instead of like crashing and burning, we can say, oh, the data we got isn't what we expected. We can deal with that how we want to instead of it crashing and burning. Any questions? Sorry we went over by 10 minutes. That is all of the tools of the trade, all of the tools we use at Hack for Impact. So we've kind of covered everything on creating an application.
Cool. Thanks for coming. No meeting next week, Thanksgiving, right?
Yeah.
Yeah, so no meeting over break, of course, so. Never mind, we will be meeting next week and we will not be meeting over Thanksgiving, so.
Thanks, everybody. We'll be back here. If you have any more questions, I can go a little bit more in depth on any of these topics. Thanks for coming.
Yeah.
So I like have it set up